Alright, it's the next day. I'm gonna keep trying to build this operating system, I guess. You'll notice I switched back to NeoVim. I was trying out Zed for a little bit, but now I'm back, so. Whoa. Wait, what just happened? My language server like died. Now. Okay, now it's good. See, this is the problem I was having. So I tried off video to get the nightly going because I was thinking maybe that was my issue. Because if I cargo build right now, I'm getting like these. Wait, I like broke everything. Alright, here's what I'm gonna do. Since this was actually like so little work I did, I'm literally just gonna start over. And try to go really fast, trying to set up everything. So I'm just gonna follow this tutorial again. Try to just fly through it. And can I like move this? Thank you. Alright, go back to all posts. The first one is freestanding Rust binary. So I'm gonna I should just do this and do that, and then just say okay, cargo new. Foo, I still want a good name for this thing. If you think of a good name, let me know. Bin. Okay, and now we can go back here. Go back here. And yeah, this should be confused. Okay, now we got like a blank project. Everybody's happy. Okay. Let's Alright, so we had the no stud. First thing, this thing gives us an error, right? We remove that. Then that was this. Panic implementation, we copy this. Oops. Oops. Now we have a panic thing. That's the same error we were getting last time. I don't know how to resolve that yet. And then we disable unwinding, which you do in cargo.toml. Probably down here. Cool. And then if I cargo build, says function main requires a standard library. Okay, I'm not sure what that means. Overriding entry point, that's what we want. Okay, no main. No main, get rid of main. And then take this no mangle. Lovely. Empty loop, waste CPU cycles. Thank you, that's helpful. And linker errors. So now if we build, it says we should get linker errors. So cargo build. Oops, cargo build. That, sure enough, is a linker error. Linking with CC failed. Okay. Now it shows that example target. We're gonna make our own target. We did all that, and let's go to the next one. We're flying through here. Okay. Install Rust 9. So this is our, I think I might have gone wrong last time. To manage, yeah, I already have Rust up. Install a nightly compiler for the current directory by running Rust up. Alternatively, you can add a file called, okay, let's do that one. Rust toolchain. Oops. Nightly. See, but now if I have that and I go like cargo, or no, not cargo. Yeah, cargo. Wait. This is not nightly. Or what is it? Rest up. Not stable. I want nightly. Okay, so now we're on nightly. But now it gives me like that weird error. Which is a little bit scary. So copy that and paste it in the Google. This is different. None of those look particularly helpful. Do these mean something in a Google search? Maybe they don't. Cargo? Oh, that's weird. Cargo. Let's try that. Ooh, this is better. It's still the stable version, but then it's not quite the same. It's not quite the same. Oh, this looks the same. Wait, it did look the same. Alright, so let's rust up, override setback to stable. Let's ask this guy. How can I set my Rust version to nightly in a project, in a cargo project? Toolchain.toml. Whoa, nobody said that. And now do what? Toolchain. Whoa. Wait, so now we're just getting a link error, whereas before we were also getting a link error. Maybe I'll just give this a shot and just try to go forward, and if it breaks, then we'll come back and try to fix it. I tried this, channel nightly, so I should be on nightly. Yeah, so then we make this file. Where did we put it? Right there. Okay. We make a new guy over here, x86 underscore 64 foo os.json. Put all this in here. Does that look good? Yeah. All right, and then just make sure I have all of this the same. And give it a shot. This same command from yesterday. All right. Can't find crate for core. This is what we were getting yesterday. It's like these. Oh, wait, where was that magic? Oh, I didn't do that. Oh, I'm supposed to get that. Check it out. No way. Let me build this up for you a little bit. Okay. And then, oh, this is where we do this. Okay. So add dot cargo slash what? Config dot toml. And then in here, say unstable. This is an unstable feature. Build stud equals, oops, core compiler builtins. We're still getting the same error. I wonder, what if I took this and put it in my cargo.toml? Long shot, but who knows what I might do. All right, let's Google this error. Cannot find crate for core. Whoa, Rusty explain, dash explain. Who knew that was a thing? Yo, what is it? Yo, 463. I had no idea this was a thing. A crate was declared but cannot be found. You need to link your code to relevant crate in order to be able to use it, blah, blah, blah. Okay. Can I quit out of that? Okay. Rust target add. Can I just do that? Huh. Wait, what's the target? Oh, do I need to like add that? Okay. And then wait, now there's a linker error. Oh yeah. Because we need that. Look, this guy's even linking to our fill op guy. Ooh, check it out. Building for a different target. You're passing the target option to cargo build. Yes. Now the compiler complains that it can't find the core library. Give you a quick overview of how to fix this problem. For more details, see the Rust cross project. Libcore. The core library is a dependency-free library that is added implicitly when using no standard. It provides basic standard library features like option and iterator. The core library is installed together with the Rust compiler, just like the standard library. But the installed libcore is specific to your architecture. If you aren't working on x86 64 Linux and pass target that, to cargo, you can't find that. To fix this, you either use rust up or xargo. Xargo? What's xargo? But I'm using a custom target specification. It said you can use xargo. What is xargo? Xargo. Looks like it's got 1,000 stars. It's in maintenance mode. Okay, wait, go back to here. Xargo. If the installation fails, make sure you have the CMake. Okay. Drop in replacement for cargo. So every cargo command also works with Xargo. You can do all those things. Okay. Build command gains additional functionality. Xargo build will automatically cross-compile the core library and a few other libraries when compiling for custom targets. So if your custom target file is named that.json, you can compile your code using Xargo through Xargo build --target. Note the omitted extension. First of all, does the omitted extension work with this? That's what I thought. All right, let's try this. Cargo install Xargo. Or is it Xargo? Xargo or Xargo? I'm going to keep calling it Xargo. All right, now we try Xargo build --target x86 _ 64 -foo os.json. I thought it was on nightly. I thought I was on nightly. Didn't I put like this in here and say nightly? See, he told me to do this though. He said do this and this and this and this and this. How was that? Okay. Rust up override set nightly. Now try Xargo. Rust C binary. Go back to stable. Try the build thing. Okay. Let's ask this guy again. Who was it? This guy. You see this good? How do I do this? Oh dear. Here we go. I tried that and it doesn't seem to be working. After doing that, if I type like cargo or for example rust C version, should it say nightly? Da-dum. Try this. And then we're getting this error again. Okay. It's all a nightly tool chain. Oh, I had to do that. Who said I had to do that? I have to install these guys. Who would have thought? Oh, whoa. getting the source and Clippy and all the good things. Fantastic. It's doing it all. Okay, while that's going, that was a different error. It was better error. Can we try? Okay, so let me try the Xargo thing. Saying I need to be on nightly. Here, I thought I was on nightly. But clearly this guy isn't working, so we'll just get rid of him. And then we'll do the other thing where we go. Rust switch. What was it? How did we do the switch to nightly? This guy. Okay. Nightly. Excuse me, where are you going? Nightly. Rust up override, that's what it is. Over. Joink. Okay. Now, moment of truth. Cargo lock is missing from Sorster? What are you talking about? It's right here. Whoa. Wait, I just tried it with normal cargo. And it worked. Which means I can get rid of this this guy. Glad we don't need him actually, because I kind of do like using the normal things. Okay. So in theory that worked. I can't believe it. I can't believe it. So here's what I'm going to do. If you're not familiar with just, you should be. I'm going to make a just file. Wait, I thought I did this last time. Maybe I didn't. Okay. Looks like I did it. So I'm going to make a just file. I think I have like a snippet for this. That. I'm going to say like build, just because it's a bit verbose to say like cargo build dash target is like my x86 underscore 64 foo os.json. So now down here I can say just, and that gives me this like fuzzy finder. Hit build, and it builds. Unused manifest key. Oh yeah, because we're not using that. Because that's actually over in this file, you know. So I'm so glad it's actually building now. And does that? Okay, now we're here. Memory related intrinsics. Compiler assumes that it shouldn't say blah 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 blah. We can't link the C library. We need an alternate way to provide these functions to the compiler. One possible approach for this could be to implement our own mem set and apply no mangle. However, this is dangerous since the slightest mistake in the implementation of these functions can lead to undefined behavior. Okay, fortunately, compiler built-ins crate already contains implementations for all the needed functions. Perfect. They are just disabled by default due to not collide with the implementation from the C library, but we don't have a C library. We can enable them by setting cargo's build, stud, features, flag, oh, cool. Okay, so go back over here. And this guy, it's features, and it's one more here. Compiler, it's like, oops. Compiler built-in map. Is that right? Added very recently. This was in 2020, so 5 years ago. Behind the scenes, this flag enables the mem feature of compiler built-ins. Perfect. Save and set a default target. Oh, you can set a default target. Who knew? To void pass. So then I don't even need my just file, right? If I can set a default target. So then in cargo config, I can go build. This is maybe at a higher level. Target equals x86 underscore 64 not block, mine's foo os.json. Lovely. And now if I get rid of my just file, if I just say cargo build, it looks like it did it for the right target. I mean, it worked. All right. Awesome, we're flying now. Print a screen. Oh yes, this is what I'm talking about. This is what my OS is gonna look like. What are those, like cards? The easiest way to print text to the screen at this stage is the VGA text buffer. It's a special memory area mapped to the VGA hardware that contains the contents displayed on the screen. Normally consists of 25 lines that each contain 80 character cells. Each character cell displays an ASCII character with some foreground and background colors. The screen output looks just like this. You know, I kind of remember there's going to be a bunch of like long QEMU commands, so I actually do want to make a just file. I take it back. But I can just, first of all, do that. Just say like build will be like cargo build. Alright, so now I can just say just build instead of cargo build. I don't know why that's better, but it's nice. Okay, and then, well, this is complicated. Yeah, the next post is all about the VGA buffer. But I think we're not going to go to the next post because then we're just going to try to hack it on our own. For printing hello world, we just need to know that the buffer is located at address 0x B8000 and that each character cell consists of an ASCII byte and a color byte. That makes sense. And the implementation looks like this. Perfect. Let's go over here and write it out. We already have all this stuff. So this is like our main. Hey. What do you mean you can't find crate for core? Help. First analyzer died. So did Copilot. Perfect. Hello? I'm getting... Wait, it told me to check the log somewhere. Messages, does that go there? No, that's not that one. Wait. Main. Oh dear. Hey, look, this is my thumbnail. Alright, well, let's just write this out without it for now and hope for the best. So, Omegle, static hello. We're going to say, okay, so static, oops, not here. Actually, can we move this down? This is like an implementation detail down here. And then this is all very well. Well, I still want that at the end. I'm going to say let VGA buffer. I'm getting no LSP. 0xB8000 it was. As star mut u8 for I and byte in hello dot, oh, we didn't make hello, we need to make hello static hello. It's okay, slice, reference to a slice, hello world in hello.iter.enumerate, and then we make an unsafe block. VGA buffer.offset I as I size times 2 equals byte, and VGA buffer, oops, offset I as, oops, I size times 2 plus 1. This is probably the color, I'm guessing. 0xB. Cool. And we cast. Oh. That's what this is. It's a pointer. Then we iterate over the bytes and we just stick them in there. Perfect. Okay. Yeah, unsafe is bad. Okay, running it. This is what I want. Now that we have an executable that does something perceptible, it is time to run it. First, we need to turn our compiled kernel into a bootable disk image by linking it with a bootloader. Then we can run the disk image in the QEMU virtual machine or boot it on real hardware using a USB stick. To turn our compiled kernel into a bootable disk image, we need to link it with a bootloader. Instead of writing our own bootloader, which is a project on its own, we use the bootloader crate. Am I cool with that? I'm not sure if I am cool with that. What if I want to make my own bootloader? Bootloader. Bootloader. 1,500 stars. Updated on February 10th. It's March. Alright, well, maybe I can live with that. It's on 0.11. This guy had it on 0.9. So maybe let's try that for now. He's adding a dependency in here. He's saying a bootloader 0.9. This is only compatible. Wait, can I still just build? No. Oh, because it's bootloa, not lao. Perfect. It actually still builds. Only compatible with 0.9. Newer versions use different build system and result in build errors when following this post. Perfect. We'll fix that later. Adding the bootloader as a dependency is not enough to actually create. Okay. Boot image. What does that do? Cargo install boot image. What did I do? Just an S. I already have it. Check it out. For running boot image and building the bootloader, you need to have that. Okay, rust up component add llvm tools preview. I already have it. Okay. Create a bootable disk image by running cargo boot image. This is doing something. Where did it go? Wait. It's in. Oh, target. Wait. Target. Debug. Wait. Debug. Boot image. Foo. Oh, right here. Oh, in here. Debug. This is it. Check it out. It's beautiful. Ooh, look, there's text down here. Okay, well, that's kind of cool. After executing the command, you should see a bootable disk image. Yep, I see it. You can boot it in a virtual machine or copy it. Booting it in QEMU. Let's give it a shot. Let me make some just commands for this, because that's going to sort of, like if I say, okay, another one that's like, well, that was build, so I don't know, could like create. Well, here's what I'll do. I'll do that and cargo boot image. And then if I say like run, then this is what I want to do. I want to say just build first, and also QEMU system x Just can I just copy this? Put this in here. But it's not at, it's and. QEMU system, okay, x86 will drive from around target. This is foo. And this is also foo. If I now just run, something happened. And would you look at that? It's beautiful. We have an operating system. And it is incredible. And I'm trapped. Uh-oh. Press Control, Option G. Wow, that's really cool. If I put this here, if I like stop this, it closes that. Hello world is working. You can also do it on a real thing. Okay, cargo run. To make it easier to run it, we can use the run it, but I'm using just, so I don't really need that. What's next? Okay, that is a really good place. I'm gonna commit git add dot git commit dash add. I am back in the open, but that's not what I want to do. I am hello world OS. Cool. Do I have? No, I don't. Okay, let me go. I made a repository, didn't I? Ow, my finger hurts. OS. There we go. Copy that. Doink. And then say get, not get remote, add origin this. There we go. Git push origin master. Check it out. You guys can all see my operating system now. Boy, is it sophisticated. Look at this. Almost as big as Serenity. Alright, that's cool. Alright, well, I'll probably stop there for now and pick back up tomorrow. Thanks for watching.